Hello students, in this video we will discuss change of scale property, Laplace transforms of derivatives, Laplace transforms of integrals. First, change of scale property. Change of scale property. If L of f of t is equal to f bar s, then L of f of a t is equal to 1 by a f bar s by a. This is change of scale property. Let us look at the problems on change of scale property. Problem. If L of f of t is equal to 20 minus 4s by s square minus 4s plus 20, find L of f of 3t. By change of scale property, if L of f of t is given, you can find the Laplace transform of f of a t. This is also in that form, f of 3t. Okay. Here a is 3. Given L of f of t is equal to 20 minus 4s by s square minus 4s plus 20. Say this is f bar s. So now L of f of 3t by change of scale property, this is 1 by 3 f bar s by 3 by change of scale property. One by 3 f bar s by 3. F bar s by 3 means replace s with s by 3 in f bar s. Okay. This is equal to 1 by 3 into 20 minus 4 into s by 3 all by s by 3 whole square minus 4 into s by 3 plus 20. That is equal to 1 by 3 into 60 minus 4s by 3. This is s square by 9 minus 4s by 3 plus 20. Here 9 is LCM. This becomes s square minus 12s plus 20 into 9 is 180 all by 9. Here 1 by 9 and 9 cancel. Taking 15 in the numerator, 15 into 4 minus s and 9 cancel here. Taking 4 common in the numerator, 4 into 15 minus s all by s square minus 12s plus 180. This is required Laplace transform. Next problem. If L of f of t is equal to e power minus 1 by s all by s, then find L of e power minus t into f of 3t. Solution. Given L of f of t is equal to e power minus 1 by s all by s. Say this is f bar s. Now to find the Laplace transform of e power minus t into f of 3t. First I have to find the Laplace transform of f of 3t and then we use the first shifting property. F of 3t. You know the Laplace transform of f of t, f bar s. Then the Laplace transform of f of 3t, L of f of 3t is 1 by 3 f bar s by 3 by change of scale property. By change of scale property is equal to 1 by 3 f bar s by 3 means replace s with s by 3 in f bar s, that is e power minus 1 by s, in place of s write s by 3, this becomes e power minus 3 by s whole by s by 3, that is equal to f3 cancel e power minus 3 by s whole by s. So now by first shifting property, L of e power minus t into f of 3t. Already we find the Laplace transform of f of 3t, that is e power minus 3s, e power minus 3 by s by s. In that replace s with s plus 1, okay, is equal to e power minus 3 by s whole by s, as s shifts to s plus 1 since there is e power minus t, okay, by first shifting property, that is equal to e power minus 3 by s plus 1 whole by s plus 1. This is required Laplace transform. Next, Laplace transforms of derivatives. Laplace transforms of derivatives. If L of f of t is f bar s, then L of f dash of t, that is the derivative of f of t, is equal to s into f bar s minus f of 0. But if you know the Laplace transform of f of t, then you can find the Laplace transform of its derivative. Okay, L of f dash t is equal to s into f bar s minus f of 0. Now we can apply this for f dash of t. Then L of f double dash of t, that means for its derivative, L of f dash of t whole dash, that is L of f double dash of t is equal to s into L of f dash of t minus f dash of 0. Okay, we are applying this property for f dash t. Then f dash of t whole dash, Laplace transform of f double dash, is equal to s into L of f dash t minus f dash of 0 is equal to s into, what is L of f dash t? S into f bar s minus f of 0 minus f dash 0 is equal to s square f bar s minus s into f of 0 minus f dash of 0. This is Laplace transform of f double dash of t. Okay. In general, we can find the Laplace transform of nth derivative of f of t. That is L of f for n of t. That means this is the Laplace transform of nth derivative of f of t is equal to s power n f bar s minus s power n minus 1 f of 0 minus s power n minus 2 f dash 0 minus and so on minus f power n minus 1 of 0. Okay, this is the Laplace transform of nth derivative of f of t. Okay, now let us see the problems on Laplace transforms of derivatives. Find the Laplace transform of t cos CAT by using the theorem of Laplace transform of derivatives. Using the theorem of Laplace transform of derivatives. Okay, see the solution? We have to find the Laplace transform of t cos at by using the theorem on Laplace transform of derivatives. Let f of t is equal to t cos at. Then press t, the derivative of f of t, t into cos at derivative minus a sin at, minus at sin at plus cos at into t derivative is 1. Okay, and f double dash of t, again its derivative, minus a into t sin at derivative, t into sin at derivative a cos at, that is at cos at plus sin at into t derivative 1 plus cos at derivative minus a sin at. Okay. Now we apply the theorem on Laplace transform derivatives for the second derivative of f, that is for f double dash of t. Okay. So we have f of 0, f of t is t cos at, f of 0 is 0, f dash of 0, f dash t minus at sin at plus cos at. If t is 0, then this becomes 0 and cos 0 is 1, f dash of 0 is 1. Okay. Now L of f double dash of t. By the theorem on Laplace transforms of derivatives, L of f double dash of t is s square f bar s minus s into f of 0 minus f dash of 0. Here actually f bar s means L of f of t. You can write in place of f bar s L of f of t. S square L of f of t minus s into f at 0 minus f dash at 0. That is L of, already we find the Laplace transform of f double dash t is minus a into at cos at plus sin at minus a sin at. This is f double dash of t. Okay, is equal to, see the RHS, s square into L of, here f of t is t cos at minus s into f at 0 is 0 minus f dash at 0 is 1. Which implies that L of minus a square t cos at minus a sin at minus a sin at minus 2a sin at is equal to s square L of t cos at minus 1. That implies, by the linear property, minus a square into L of t cos at minus 2a into L of sin at is equal to s square into L of t cos at minus 1. That implies, this is s square into L of t cos at. Send this to RHS and take L of t cos at is common, s square plus a square into L of t cos at is equal to 1 minus 2a L of sin at. That is equal to 1 minus 2a into L of sin at is a by s square plus a square. That is equal to s square plus a square minus 2a square, s square minus a square whole by s square plus a square. Okay. From this L of t cos at, send this to RHS, s square minus a square whole by s square plus a square and s square plus a square that is s square minus a square by s square plus a square whole square. This is required Laplace transform. Next problem. If L of sine root t is equal to root 5 by 2s power 3 by 2 into e power minus 1 by 4s, then find L of cos root t by root t. L of sine root t is given. See the solution. L of sine root t is equal to root 5 by 2s power 3 by 2 into e power minus 1 by 4s. Let f of t equal to sine root t. Then L of f of t. Sine root t Laplace transform is root 5 by 2s power 3 by 2 into e power minus 1 by 4s. So now f dash of t. F of t is sine root t. Its derivative, sine root t derivative cos root t by root t derivative to root t. And f of 0, here f of t is sine root t, f of 0 is 0. So by the theorem of Laplace transform of derivatives, by Laplace transform of derivatives, L of f dash of t is equal to s into f bar s minus f of 0. L of, what is f dash t? Cos root t by 2 root t is equal to s into f bar s, that is L of f of t, already given, that is root 5 by 2s power 3 by 2 into e power minus 1 by 4s minus f of 0 is 0. That implies 1 by 2 into L of cos root t by root t is equal to s by 2, 1 by 2 into s cancel here, root 5 by s power 1 by 2 e power minus 1 by 4s. That implies both sides 1 by 2 cancel, L of cos root t by root t is equal to root 5 by s power 1 by 2 means root s e power minus 1 by 4s. You can also write this as root 5 by s e power minus 1 by 4s. This is required Laplace transform. Next, Laplace transform of integrals. Laplace transforms of integrals. If L of f of t is f bar s, then L of integral 0 to t f of u du is equal to 1 by s f bar s. Similarly, L of integral 0 to t f of u du is equal to, that means 2 times integration. The Laplace transform of integral is 1 by s f bar s. Here f bar s is the Laplace transform of integrand. This is equal to 1 by s into the Laplace transform of this integrand, that is 1 by s f bar s, that is equal to 1 by s square f bar s. In general, L of integral 0 to t and so on integral 0 to t f of u du and so on du n times is equal to 1 by s power n f power of s. Understand? Let us look at the problems on Laplace transforms integrals. Problem. Evaluate L of integral 0 to t e power minus u cos u du. See the solution. Let f of t equal to e power minus t cos t. Then L of f of t is equal to L of e power minus t cos t. By the first shifting property, first we have to find the Laplace transform of cos t and then replace s with s plus 1. L of cos t and then s shifts to s plus 1 by first shifting property. Okay? And you know that L of cos t is s by s square plus 1. S shifts to s plus 1. That is s plus 1 by s plus 1 whole square plus 1 is equal to s plus 1 by s square plus 2s plus 1 plus 1. That is 2. Okay. Say this is f over s. That means L of f of t is f over s. Now I have to find the Laplace transform of integral 0 to infinity 0 to t e power minus u cos u du is equal to 1 by s f bar s. That is 1 by s into what is f bar s? S plus 1 by s square plus 2s plus 2 is equal to s plus 1 by s into s square plus 2s plus 2. Understand? Next problem. Evaluate L of integral 0 to t cos au du. That means 3 times integration here. Okay. See the solution. Let f of t equal to cos at. This is f of u means f of t is cos at. Okay. Then L of f of t is L of cos at is s by s square plus a square. Say this is f bar s. So now L of integral 0 to t cos au du. 3 times integration here. This is in the form integral 0 L of integral 0 to t f of u du. That is equal to 1 by s cube f bar s. Since 3 times integration here, 1 by s cube f bar s. That is 1 by s cube. And f bar s is s by s square plus a square. That is equal to s cancel here. 1 by s square into s square plus a square. This is required Laplace transform. Okay students. Thank you so much for watching. See you in the next video.